Okay, so section 10.2, we were talking about simple interest, but that is not the way most financial institutions work. And so in section 10.3, we talk about compound interest. Compound interest. When a loan is based on compound interest, the interest accumulates. First, you pay interest on the principal. Next, you pay interest on the principal and the interest, and so on. Think of a rental where the rental cost goes up each time period. So let's look at a specific example here. Okay, so suppose you invest $1,000 into an account that earns 6% annual interest. What will be the balance after 1 year? Okay, so might want to pause the video and try this on your own. Right. So again, here this is not a basic percent problem, because you are not just working with the percentage and the whole. So you are investing $1,000 and your account earns 6% interest, and what will be the balance is what we are being asked, not how much interest do we collect, right? So first, we can do this in two ways, in 2 steps. First step is to calculate the interest, right? And so then the interest we went over last time is the principal times the rate times the time. And the time here is 1 year. And the principal is the $1,000. And the rate is the 6%. So then the interest is the principal, 1,000, times the 6%, 0.06, times the 1, which is $60. So you will collect $60 in interest. But the question is asking for the balance. And so our balance is going to be the $1,000 that we started with, plus the $60 in interest that we just made. So 1,060. Okay. And we've done something like this before. So just some vocabulary. What we've done is we've just gone through a percent increase, or we've gone through a 6% increase. We started out with $1,000. After a 6% increase, we ended up at a balance of 1,060. And so what we say, the vocabulary that we use, is that we have gone through one compounding. So we have compounded once at a rate of 6% to end up at 1,060. Now we're going to want to compound, and we're going to want to do this a little quicker than what we just did here. And so let's now derive another formula. You invest P dollars in an account that earns an annual rate R. What will be the balance after 1 year? Okay, so again, we'll use F for your future value, and then that is going to be how much money you started with, which was P, plus the interest that you collect. And the way we calculate the interest is P times R times 1, and since it's just a 1, we don't write the time. We're only going through one compounding, so it's P times R. And so then, for the purposes of doing this even quicker, we can see that both of these have a P, so we can factor out a P like you did in algebra. And when you factor out a P, then you put a parentheses and you ask yourself, P times what will give me this P? And that again has to be a 1, right? You have 2 terms. When you factor out, you need to have 2 terms inside the parentheses. Plus, P times what will give me PR? 1 plus R. And so then what this tells you, right, is that when you go through one compounding, you can figure out the future value, the new value, by just taking your principal, how much you started with, and multiplying by 1 plus R, and you can do this a little quicker, right? So in our previous problem, we had the $1,000 that we were starting with, and then we were going through a 6% interest, 6% increase. And so then if we just add the 1 and the 6, we can do that in our head is 1.06. And then we can punch that into the calculator, 1,000 times 1.06 which gives us 1060. Same thing, just gets done a little quicker. This formula is going to be very useful. So I'll write this down for you. The new amount after one compounding is given by the formula P times 1 plus R. Okay. Now, in section 10.1, we did this problem and it took up the entire screen because basically I was going through step by step and hopefully that made it more clear as to how to get to the final answer. But with this new formula that I've just given to you, let me show you how you can make this problem go a lot quicker and a lot cleaner. So this is over a period of 1 week, the Dow Jones Industrial Average did the following. On Monday, the Dow Jones Industrial Average went down by 3.2%, right? So then the percent, the new amount is the percent decrease. So 1 instead of plus, because we're not an increase, it's 1 minus 0.032, which is 0.968. You're going to take 0.968 and multiply it times whatever it started at. We don't know what that is. But now this is our new amount, right? 0.968p is what it was worth at the end of the day on Monday, right? On Tuesday, it went up by 11.12%. So then we're going to multiply this amount by 1.12. I'm sorry, 1.112. Right? Because your R is 11.2%. Move the decimal point over, 1 plus that, 1.112. On Wednesday, it went down, it went up by 0.07%. So on Wednesday, it went up by 0.017%. So then we're going to take this amount right here and multiply it by 1.007. Okay. On Thursday, it went down by 4.8%. And so that one we're going to multiply now by 1 minus. So it's going to be 1 minus 0.048, 0.952. And then we're going to then, on Friday, it went down by 9.4%. So 1 minus 0.094, 0.906. And so then if we multiply all this out, we don't have to go through like we did last time. We can just multiply all this out. 0.906 times 0.952 times 1.007 times 1.112 times 0.968. And that gives us 0.9349p. And so this is where it ended up. And so then again, the question was, what was the percent increase? Well, so again, we can look at it as having gone through just one compounding. And if we had just gone through one compounding, we would have taken our principal, P, and multiplied it by 1 plus R. We don't know what the R is. And it turns out that it doesn't matter what the P is, because now we can divide both sides by P, and the P's go away. And you get 0.9349 equals 1 plus R. And if you take your 0.9349 and you subtract 1, and you get the same answer that we got last time, negative 0.0651, which is, it decreased 6.51% over the week. So I just wanted to do that problem again for you using that formula. Every time that you go through a percent increase or a percent decrease, you can just multiply by 1 plus r, right? If you're increasing, it's a plus. If you're decreasing, it's a minus. So we started out at, go through this again real quick. We started out at P, then we multiplied it by 0.968 because we went through a 3.2% decrease, and then we went through an 11.2% increase, so we multiplied that by 1.112, and then we went through a 0.7% increase, so we multiplied it by that, and then we went through by a couple of decreases, and so on and so forth. Okay, so the point of that example and the previous formula is the usefulness of this new formula, that every time you go through a every time you go through a compounding, you simply multiply by 1 plus r, right? So you invest $5,000 in an account that pays 6% annual interest compounded annually. Complete the table. Okay, so compounded annually means that this is not simple interest, right? You're getting paid every year, and the next year you get paid on what was in the account the previous year, not what you initially invested, right? So let's go through this real quick. So actually, you should pause the video and try and fill out this table on your own. And keep in mind that every time you go through a compounding, the easy way of getting there is by multiplying by 1 plus the interest rate. And in this problem, your annual interest rate is constant of 6%. Okay. Okay. So when no time has gone by, you only have the money that you put in there, which is your $5,000. Right? Now, 1 year has gone by and we've gone over how to figure this out. You just multiply the 5,000 times 1.06. And at the end of the year, you now have $5,300. Now, this is how much money is yours now. You've been paid already. You have $5,300. So the next year, they're not going to pay you another $300 because you have more money in the bank. You're going to get paid more. So what you're going to do is you're going to multiply the 5,300 by the 1.06, and you will get $5,618. Notice that the first year you made $300. The next year you made $318. It should make sense that you made more money because you had more money in the account. This is not simple interest, right? You're not getting interest just on the original amount. You're getting interest on the interest. That's why it's called compound interest. So the next year you have $5,618 in the account, and then you're going to multiply that by 1.06, and now you will have $5,955.08. And then that's how much you have in the account. So the next year you multiply that by 1.06, and you get $6,312.38. But what we're really interested in doing is figuring out how much is in the account after 30 years. Okay, now we don't want to do this step by step all the way till we get to 30. That's going to take way too long. So we would like to look for a pattern. Unfortunately, by actually carrying out the calculations, we're losing the pattern, right? And so how did we get here? We took the 5,000 and we multiplied it by 1.06. And then we took this number and multiplied it by 1.06. So rather than carrying out any of the calculations, we can just write it as 5,000 times 1.06 times 1.06, or 5,000 times 1.06 squared. And then we just multiply this number by 1.06. We're going to have one more factor of 1.06, so you will get 5,000 times 1.06 cubed. And then to get this number, you're going to take the 5,000 times 1.06 cubed and multiply it by one more 1.06. You will get 5,000 times 1.06 to the fourth. And now you have a very obvious pattern, right? When it's, they all have a 5,000, 5,000, 5,000, 5,000, 5,000, 5,000. So for 30, you should have a 5,000 times 1.06. They all have a 1.06 except for that first one. And the only thing that changes is the exponent. When the exponent is 1, your exponent is 1 here. I'm sorry, when your time is 1, you have a 1 here. When your time is 2, you have a 2 here. When your time is 3, you have a 3 here. And so it should make sense then that for 30, you have 30. Now you need to learn how to use your calculator to do things like this. You don't want to do 1.06 times 1.06 30 times. So you're going to have either a button that looks like this, not like that, that looks like this, and that means to the, or you'll have a button that says x to the y or y to the x. That's so that you can put in a different exponent. And what you're putting the exponent on is the 1.06. So you're going to do 5,000 times 1.06 raised to the 30th power. And then we end up with 28,717.46. Had we done this using simple interest, then what you would get would be 5,000 times your rate is 0.06 times the years, which is 30 years. We would have only made $9,000 in interest. And since we started out with 5,000, let me write that down, simple interest. Using the simple interest formula, you would have collected $9,000 in interest, and you started out with 5,000, and so then your total would have been 14,000. It's a lot more, almost twice as much more by doing compound interest as opposed to simple interest. And it should make sense that once I got paid the interest, that is now my money, and so I should collect interest on that interest. Okay, so this leads us to our next formula. If we generalize from this example, we get this next formula, the annual compounding formula. The future value f of p dollars compounded annually for t years with an APR expressed in decimal form is f is equal to p times 1 plus r to the t. So find the future value of an investment of p, which is $1,237.50, compounded annually with 8.25% APR for a term of A, 3 years, and B, 4.5 years. Okay, so again, you should know which formula you're using. So find the future value of an investment of $1,237.50 compounded annually. So it does not say simple interest, it says compounded annually. So you should know that you're using the formula. Your future value will be your principal value times 1 plus your rate raised to the t. Your future value is what you're trying to compound. Trying to figure out. F, your principal is $1,237.50. 1 plus, the 1 plus we can do in our head, 1.0825. And we're going to raise this to the t, and t is 3 years. From there, it's just punching it into the calculator, $1,237 times 1.0825 raised to the third power. And you end up with $1,569.74. Now, if you've agreed to compound your interest annually, then you don't get paid until the end of the year. So if you don't get paid until the end of the year, and you pull out your money halfway through a year, you don't get paid for that year. So this part B says 4.5 years, but we basically lose that half year. And so then our T value there is 4. So our future values, what we're trying to calculate, we have $1,237.50 is our principal. And we still have the base of 1.0825, but now our exponent is just 4, not 4.5, because we're compounding annually. We don't get it. We don't get anything for that half a year. Okay, and so second. If we just change that exponent to a 4, we get $1,699.25. Okay, so between 2000 and 2011, the average annual inflation rate was 3%. Find the salary in $2,000 that would be equivalent to $50,000 salary in 2011. Okay, so again, no simple interest here. Every year, the annual inflation rate was 3%, right? So that is your R. You're using the formula that your future value, you're doing this for multiple years, is your principal times 1 plus your R to the T. The annual inflation rate was 3%, so R is 0.03. Find the salary in $2,000. That means we don't know what our original salary was. That would be equivalent to $50,000 salary in 2011. So our future value is 50,000. And we're going from 2000 to 2011, so we're going through a period of 11 years, right? So 2011 minus 2000 is 11 years. And so now we can just substitute that into the formula. Your future value is, you want to compare your salary in 2000 to your salary in 2011, so that's 50,000. And that is equal to your original salary from 2000, we don't know, times 1.03 to the 11. Now, again, we can clean this up. Too many zeros. We can clean this up to 1.03 raised to the 11 is 1.384 rounded off. $1.384 times P. And to figure out what P is, we simply divide both sides by 1.384. So 50,000 divided by 1.384. 36,127.17. So if you started out with a salary of $36,127.17 and increased it by 3% every year in 2011, in 11 years, it would be $50,000. Another way of looking at it. Okay. So as we saw in our earlier example, where the half a year was wasted, we agreed to keep our money in the account for an entire year before we got paid. And when we had it in there for 4.5 years, we didn't get paid for that half a year. So that seems rather unfortunate. And so then the question is, well, could we get paid more frequently so that we don't have to wait as long? So to minimize the amount of loss in case we pull out our money earlier. So that's what we're going to explore next. So you deposit $10,000 in an account that pays 12% annual interest compounded monthly. And again, compounded monthly means that you are going to get paid every month. So we don't have to wait that whole year. So we will have gotten paid 6 times during that half a year, and we wouldn't have lost that money. But the rate is always given to you as the annual percentage rate. And so the point of this slide is to get you comfortable with, well, if I'm getting 12% for the entire year, how much would I get for 1 month? It should make sense that I should get, since a month is a 12th of a year, I should get a 12th of the 12%. So I should just get the 12%, and I divide it by the number of months in a year, 12, and every month I don't get 12%. Every month I get 1%. Well, that should make sense, right? And so that's what it is. So now we know that every time we're going to, every time we get paid, we're going to get 1% of our balance. So you deposit $10,000 in an account that pays 12% annual interest, compounded monthly. What will be your balance after 1 month, right? And so then the future amount will be the principal amount, 10,000. And after 1 month, we're only going to go through one compounding. So we're just going to multiply by 1.01, right? Because every time we're going to get 1%. And so 10,000 times 1,100. Sorry, $10,100. Okay. So what would happen after 1 year? Well, after 1 year, we'd have to go through it month by month. So for the second month, we'd multiply this by 1.01. For the third month, we'd multiply that by 1.01. And you would see the same thing that happened on the table before, is that you would just be changing the exponent. And the exponent is just going to be the number of compoundings. So after 1 year, since we compounded once a month, we will have gone through 12 compoundings, and so you would get 10,000 times 1.01 raised to the 12. And so what we would get is $1,268.25. Now, if we were compounding just once a year at 12%, the 10,000 times the 1.12 would have been 11,200. But by compounding every month, we made an extra $68.25. So when we go to do this after 20 years, and then again, every time our principal is the same, 10,000. Every time we compound, we multiply by a factor of 1.01. But after 20 years, since we're doing this every month, it would have been 20 times 12, 240 times. So our exponent will be 240. And so we get 10,000 times 1.01 raised to the 240, which is $108,925.54. So in 20 years, we will have taken our $10,000 and made it into $108,925.54. But an annual interest rate of 12%, you're not going to get that from a bank. You can get that through other places. The average return on the stock market is 9% or 8%, something like that. And if you go a little bit riskier, you might be able to get more than that, but there's risk. Okay. And so this gives us our next formula. This is called the general compounding formula. So F is equal to the principal times 1 plus P raised to the capital T, where F is the future value, P is the principal, lowercase p is the periodic interest rate. So typically what is announced is the annual interest rate. And so then that's not how much you're going to get every compounding if you're compounding other than once a year. So if you're compounding once a month, then you're only going to get a 12th of that. If you're compounding quarterly, then you're only going to get a quarter of that. If you're compounding daily, then you're only going to get 1/365th of that. And T is the number of times the interest is compounded. Okay. So consider a CD paying 3.6% APR compounded monthly. Find the periodic interest rate, right? So in part A, you're being asked to find the periodic interest rate, which is how much, what your rate is per compounding. You're getting 3.6% for the year, but you're doing this every month, so you're not going to get 3.6% every month, so you just divide that by 12. So when you take the 3.6 divided by 12, you get 0.3%, which can also be rewritten as 0.003 for every month. Now, find the future value of a CD if you invest $3,250 for a term of 4 years. So now you're using the formula F is equal to capital P, principal, times 1 plus little p, your periodic interest rate, raised to the capital T, and T is the number of compoundings. So your principal is 3,250. Your periodic interest rate is 0.003, so we can add 1 to that. In our head, we don't need a calculator for that, 1.003. And then we're raising it to the 4 years, but we're doing this monthly, so 4 times 12 is 48. You're going to compound 48 times because you're doing it every month, and you're doing it for 4 years. So now it's just a matter of punching it into the calculator. You need to make sure that you know how to use your calculator. And what you get is $3,752.56 after 4 years. Consider a CD Consider a CD paying 4.38% compounded daily. Find the periodic interest rate and find the future value of the CD if you invest $3,250 for a term of 4 years. Okay. So then for part A, you you're going to do this every day, and there are 365 days in a year. So you're going to take your 4.38 and you're going to divide it by 365 to see how much you get every day. So 4.38 divided by 365 is 0.012%. Don't forget the percent symbol. That looks like a percent, but it's not a percent. You need the percent symbol. Now we move the decimal point over another 2 places. So you're going to get 3 zeros in front, and that is your periodic interest rate, right? Now, we do this one a little slower. We want to find the future value. That's what we want to find. The principal, if you invest 3250, that's 3250. The little p is the 0.00012, and then the t, you're doing this every day for 4 years. So t is 4 years times 365 times each year. So 4 times 365, 1460. So you are going to compound 1,460 times. And so then your future value will be your 3250, 3,250 times 1.00012 raised to the 1460. So 3250 times 1.12312 raised to the 1460. And it doesn't do a whole lot to compound a lot, and so you get $3,872.28. Okay. So at first glance, it might seem like compounding more times per year gives you more money, and it does a little bit. But here's a table. I just copied this right out of the book because I didn't want to go through all these different calculations. So table 10.4 shows the details of the general compounding formula when applied to a 15-year CD, T equals 15, with the principal of $1,500, an APR of 4.8%, using annual, semi-annual, quarterly, monthly, and daily compoundings. Right? So if we just did this once a year, after 15 years, we'd end up with $3,030.47. By doing it twice a year, we up the amount by roughly 25 bucks, right? We end up at $3,055.55. But then when you go from twice a year to 4 times a year, you only squeeze out another $13. And then instead of every 4 months, you go every month, you still squeeze out another $9. But when you go from every month to every day, then you're going to squeeze out just another $4. And if you tried going every hour or every second, then you would find out that you really wouldn't get that much more. And so then this is over a 15-year period, right? And so it seems like it's limiting. There's a limiting as to how much you can squeeze out of this. And so it turns out that the limit is called continuous compounding, right? So we're going to use this formula, F equals P e to the RT, where F is the future value of the principal, R is the annual interest rate, and T is the number of years of continuous compounding. And so what continuous compounding means that you are not waiting a year to compound. You're not waiting a month, a day, a second, even a millisecond. It's just always happening. But it turns out there's a limiting value and it doesn't really change things that much. But it is a nice formula. a pretty challenging idea to wrestle with, but it works out very nicely. Consider a CD paying 3.6% APR compounded continuously. Find the future value of the CD if you invest $3,250 for a term of 1,000 days. Round your answer to the nearest dollar. Right? So again, you have A is equal to P e to the RT, so you need to read the problem, and when it tells you compounded continuously, then that tells you you need to know this. So R is 0.036, right? P is the 3,250, and then T is the only thing that is a little bit challenging here. T is the time in years, and you're not given the time in years, you're given that there's 1,000 days. But if we divide the 1,000 by 365, then we can figure out how many years we're talking about. And rounded to the nearest tenth, or rounded to the nearest hundredth, it's 2.74 years. And so the benefit of compounding continuously is we really didn't have to round this off at all. We could have just used the entire decimal because we don't lose any of it, right? So, but we'll round it off just for the sake of being able to plug it in correctly. And so now we just plug it into the formula, the new amount. Oh, I'm sorry, I used the wrong variable here. The new amount, the future amount is the original amount, 3250, times E. E is a number named after Leonard Euler. It's 2.71 something. It goes on forever. And your exponent on E is your 0.036 times the 2.74. And so 3250 times e to the 0.036 times 2.74. And you have to figure out how to use your calculator. I can't help you with that because there's lots of calculators out there. But you do have an e to the button on a lot of your calculators. You need to look for that and then go over how to use that. And so here we get $3,586.92. And there we go. Okay. There's the APR, that's your annual percentage rate, and then there's the APY. I've gone in to buy stuff and I've asked people, what's this APY? And they don't know. So nice to know. But the annual percentage yield, sometimes called the effective rate, is the annual percentage rate increase on the value of an investment or loan when both the APR and the frequency of compounding are taken into account, right? So if you are given an annual percent rate of 6%, but you're compounding monthly, at the end of the year, you will have gone through a bigger increase than 6%. The amount of the increase is the APY, right? So the effective yield. So let me go through this with an example. Find the APY for an APR of 3.6% compounded A yearly, right? So since it does not matter how much you started with, right? Let me go ahead and just do this with P, right? So For part A, we have the formula that after we're doing it yearly, and so then we have the formula. Your future value will be P times 1 plus R raised to the T. But your T is 1. So you want to see what happens to your value after 1 year. So your future value is going to be 1.036 times P. Now you went from P to 1.036P. So then what percent increase did you go by? Did you go up? So so what we can do is we can subtract what we started at, which will then give us 0.036P. And then we divide that by what we started at, P, and the P's will go away, and you get 0.036, which is 3.6%. Now, we didn't have to go through all this because we were compounding once a year the effective yield and the APY and the APR are going to be the same. But I just wanted to go through this calculation with you. You find the future value, here it is, and then see what percent increase did you go up. So to figure out your percent increase, you subtract your original amount to figure out what was the amount of increase, and the amount of increase was 0.036P, and then you divide it by P, and if you notice, the P's go away, so it made absolutely no difference. It made absolutely no difference what value we started with. So on problems like this, it's easiest to just say that your original value was $1, right? So for part B, right, your future value of $1 is going to be your original amount, $1, which we don't have to write because it's just a 1, times 1.036. Oh, I'm sorry, that's not right. You're compounding semi-annually, so 0.036 divided by 2 is 0.018. So 1.018 is what you're going to get every time. But you're going to go through 2 compoundings in 1 year. So your exponent is 2. And so then you get 1.018 raised to the second power is going to be 1.036. So your dollar grew to $1.36. But then if we subtract what the dollar was, I'm sorry, if we subtract the dollar that we started with, you get that your APY is 3.63%. So by compounding twice a year, you added these 0.03%, right? So C, monthly. Let me go ahead and get rid of this. So what we want to do is see what happens to $1. Again, what's going to happen to $1 is it's going to become $1 times 1 plus 0.036 divided by 12. And what's going to happen to $1 after 1 year? But after 1 year, we're going to go through 12 compoundings. So our exponent is 12. So if we punch that into the calculator, 1 plus 0.036 divided by 12 raised to the 12th power. Now you have 1.0366 if we round it off to there. And so then our dollar became this. And so then our APY, we have to subtract away the dollar that we got. I'm sorry, that we started with. We started off with $1. It became this. And so then this part right here is your APY, 0.0366. And so for the last one, compounded continuously, and now you are using your future value is equal to your principal, $1 times E to the R, and the R is 0.036, and your T is 1. You're seeing what happens to $1 after 1 year, right? And so then if you take E and you raise it to the 0.036, you get 1.0366. It should be a 7. We round it off to there. And so then again, your annual percentage yield is now 1.036. Sorry, so you take away the 1 and you get 3.67%. Not that much different than compounding monthly. And so then the point of the APY is so that you can compare apples to apples. You compare the effective yield. If they change the terms on you, you can see which one's a better rate. There's your homework. Both 10 to, so all of 10.1 through 10.3, all of this will be due next Wednesday. On Monday, I will at 6 o'clock, I will host a conference to help you out with any of the questions that you have from this section. And stay safe. Have a good night. Bye.